Let's start with section 4.1. Let's see what it says and define one-to-one function. So one-to-one function is a function f. A function f, it says one-to-one function if a and b in the domain of f. Let's go back. That's how we're gonna prove the function is one-to-one. If you take a and b in the domain of f. So if you took a not equal b, then f of a should be not equal f of b. This is the first case you can prove that the function is one-to-one, okay? Or you can say if you took f of a and f of b from the domain, from the range, then a should be equal b. We're gonna do that with numbers. How to use, if they give you two functions and you need to prove that the functions are one-to-one. But with the graph, how are we gonna do that if we have a graph like this one? Now let's check here. If you remember before, when we have to see if this is a function or no. You remember how we do that? This is x, y. We have 1, 2, 4, 6, 3, 4, 5. Remember when I told you this column is referred to the person and this column is referred to the place. So let's say person number 1 goes to place 6. Person number 2 goes to 3 and goes to 5. And person number 4 goes to place number 4. So you can say, okay, this is a function. I have one person going to how many places? 2 places. That's the only condition. Make the function, make the relation, not a function. When there's a person going to 2 places, can you do that? No. Can 2 persons go into 1 place? If you just imagine, can 2 persons go into 1 place?
Yes.
Yes. 100 people, they go into the college, which is 100 people, 100 person go into the college, so it's fine. But can 1 person go into more than 1 place on the same time? No. So that's the only condition when you have 1x going to 2y, going to be what? Not function. So this is the condition, make the relation we have not a function. Now let's, the same example, but we're gonna do adjustment on it. As 1, 2, 4, 3, 6, 5. See, this one goes here. Now, if you look, each person going to 1 place, 1 goes to 5, 4 goes to 3, 2 goes to 6. So it's fine. That means this one is, the relation is a function. We look into the person and the places. We look into the person and the places. So now it's function. Now, what about if we do the opposite thing? If we consider this is the domain, this is the range, right? What about if I flip the whole relation? I'm gonna consider this is the domain, the new domain, okay? I'm gonna say this is the new domain and this is the new range. I'm gonna flip the relation, okay? This is now the person and this is the place. You got the idea? We did the first one, we proved that as a function. Now I'm gonna flip the whole relation. I'm gonna say this is the domain and this is the range. This is the person and this is the place. Now person 3 goes where? Place 4. Person 6 goes where? 2. Person 5 goes where? Each person going to one place. Is that okay? So the second part, let's say it's the inverse. It's called the inverse. The second part, when from what? From X to Y, the first part, and here's the second part. From X, because I'm going to consider this is X and this is Y. It's what? It's a function, right? If the condition 1 satisfies, if the condition 2 satisfies, or you can call the function, it's called 1-to-1. You're right, but we're gonna call it 1-to-1. Why? Because when you flip the relation, X to Y, it's a function. Y to X, it's a function. So you're gonna call it 1-to-1 function. This is the second part, is the inverse. Okay, it's the inverse of the relation. You get the idea? That's what will happen here. Now, if you look to this small graph here, they ask you, check if this function is 1-to-1 or no. The first condition. I'm gonna consider this is X and this is what? Y. Let's say it's a function or no. Batman goes where?
Okay.
Green, whatever goes where?
So that's true.
This one goes where? So each person going to one place. Yeah, imagine that. But you see, they put persons. So imagine that persons going to one place, it's fine. So this is the first condition. This one is what? Function, right? So that's good. Now, if you flip the relation, I'm gonna consider this is X and this is Y. This is the person now, and this is the place. This person going to one place. This person going to one place. This person going to one place. So the second condition is what? Is also satisfied. So in this case, the function is 1-to-1. You're just gonna type 1-to-1. Because the function, when the function is 1-to-1, that means it has inverse. You get the idea? Where is the inverse? When you flipped it. Person going to place. This is the function. Taking the person to the place. It's a relation. It's a function because each person going to one place. If you flip the relation by making this one as a person and this one the place, that means you're doing the inverse. And you did make sure one person here going to one place. So the inverse is a function also. When the inverse is a function, that means we called it 1-to-1. Is that okay? What about next example? Always, I'm telling you, when we have example like this, try to make 2 columns. 2 small columns to make it easier for you. Let's load it up so we can solve it. So I'm gonna make 2 small columns, 1, 2. We need to prove that the relation defines from Y is 1-to-1. I'm gonna consider this is X and this one is Y. Now 2 goes where? Be careful. Each point here with X, Y. Number 2 with the X goes where? To Y, which is 1. Number 4 is X, goes where? To 2. Now 7 is a person going where? 3. Now the last one is -2 goes where? Do I have to write down 1? It's already there. Don't repeat the numbers. Goes here. Now if you look, I'm satisfying the first condition. Each person here going to one place. Oh, check here, Carlos. Each person here going to one place. 4 one place, 7 one place. Yes, 2 and -2, they are different numbers, different persons, and going to same place, it's fine. So the first condition, yes, it's a function from X. The relation is a function from X to Y. Now let's do the opposite thing, which is the second condition. Let's prove that if I consider this is the person and this is the place. Now person 1 going to how many places? 2 places, that's not okay. So condition, the second one is not satisfied. In this case, you can say it's not 1-to-1 function. Sometimes they type it like this, 1-to-1. When you see it in the book, with a small parenthesis, it doesn't mean 1 minus 1. It's mean 1-to-1 function. When you read in the book, sometimes you will see this condition. 1-to-1, instead of writing now this, 1-to-1. Okay, so it's mean 1-to-1 function. Let's check these graphs. Remember when we always need to check what the function is. We need to check the function is 1-to-1, right? Or the relation is 1-to-1. So the first condition, if you remember that when we have a graph, we need to make sure each x going to 1y. So we're gonna use vertical line test. Remember that? Vertical line test. That's what we're gonna do now. Now, if you look at the first graph, the first, this one, number 3. Vertical line test. Can I graph vertical line test on each point? Because it's not a graph, it's a point. So if you put vertical line test here, and another one here, and another one here, you see each x here going to where? To 1y. Each x here going to 1y. Each x here going to 1y. Is that okay? It's okay. Each x going to one place. Each x going to one place. And you see there are different places. So it's fine. So the first condition with this example, it's satisfied by doing the vertical line test. Vertical line test. What about the second condition? How are we going to satisfy that?
We check the y going down to the x.
We're going to check the y because we need to check each person in the y going to 1x, the opposite thing.
Check horizontal.
Yes. So it's going to be with the second condition is a horizontal line test. It's not a vertical. So the second condition is horizontal line test. That's what we're going to do. We're going to do the opposite thing. Because remember, we flipped the whole relation. We considered the y is the domain and the x is the range. So the y is the, so we're going to do horizontal line test. Now, each y here going to 1x here. At this point, there's only 1x. Like you're going to check the y intersect with the graph in 2 points. The y intersect with the graph only 1 point here. What about this point? Same thing. What about this point? Is that okay? So each y here going to 1x. So it's fine. With the graph 3, the second one is satisfied. So it's going to be 1-to-1. Here is going to be more clear. Let's do the first condition. Because this graph is continuous. let's check here. If I need to prove the vertical line test, I'm going to graph what? Vertical line test here. You can graph one here. Graph one here. Whatever, how many graph in text, that's fine. Vertical line test. Now, if you check on this line test, each X here on this point goes to how many Y? 1 Y. Each X like intersect with the graph and at what point? The X here intersect with the graph at this point. The X here intersect with the graph at this point. The X here intersect with the graph at X point. Check all the lines, it's fine. So the first condition is satisfied. Okay, let's do the opposite thing. Is that okay? Now the opposite thing. One horizontal line test will be enough. Each Y here intersect with the graph at how many points? Here is the first one, right? Second one, third one, fourth, fifth, sixth, seventh. That means this person going to how many places? 7 places. It's impossible. Is that okay? Because we flipped it. Remember, we saying, remember when we have 2 columns? We're gonna consider this is the domain and this one is the range. So that's why we're gonna do the horizontal line test. I'm gonna check each person here, which is the Y, going back to 1 place. Is that okay? So this person, how many places? 1, 2, 3, 4, 5, 6. 6 places is impossible. 7, because there's another point here. So in this case, the second condition is what? It's not satisfied. So what's that mean? This is not one-to-one function. Is that okay? So the third one, he said it's not even a function. Because let's do the first condition. The first condition with vertical line test. So check here. Where you're gonna grab the line? Here. Let's do it here.
Because if for like half it goes up vertical, right?
It's a vertical.
Or
Kind of, it's not super clear, but kind of there is more than 1 point here. Oh. It's not clear. Yeah, because they consider it's a function. That means here's only 1 point.
okay, it's only 1 point.
Yeah, like it's a little bit confusing. I know that, but they're saying here at this X, it's only 1 Y.
Okay.
So, but what about the same graph look like this? That's basically no. You can tell, but this one is not that much clear with the graphing. But you get the idea. But what about the second condition? Let's say the first condition sets 5. The second condition, it's horizontal line test, and you can tell when you graph horizontal line test, at this Y goes to 1 place. If you graph another one here, and this Y goes to 1 place, so it's fine. So the second condition is going to be satisfied, and then in this case, going to be one-to-one function. But that's important because there is no graph. There is 2 ways. You can tell me the second way. The first way, we need to use this, what they're telling you here, which is, what does that mean, f of A? When I'm telling you f of A, what does that mean?
X,
Which mean f of X, but what does that mean?
just A.
It's the X.
Well, okay, no. Answer me as a math. What's the meaning of f of A?
number from X.
which is okay. What's that mean?
That's the answer.
What's that mean? That's the answer. What does that mean? Perfect. That means it's y.
Why?
It's mean the y. Where is the input? When I'm saying f of a, when I'm saying f of a, what's that mean? This is the x, right?
Yes.
X equal a, y equal what?
Why?
That was a.
When you plug in a in the function, you're gonna get the y. So you got the idea? Keep this one in your mind. So what's the meaning of y? X is the input, right? Y is the output. It's the range. The domain is the X, the inputs. The range is the Y. So it's the same concept. You just have to know what you're doing. Domain and range. So now we need to prove this condition. Because if this condition is satisfied, what does that mean? The function is 1-to-1. Is that okay? The condition, what's that mean? If I took two values from where? What's the meaning of a?
Why?
From the range, which is y. So if I took two equal values from the range and I solve it and I found they are the same values are equal in the domain, so it's mean what? It's mean 1-to-1. Is that okay? We're gonna solve it. The question is there is another way, because here is the function, right? If there is another way to prove that it's 1-to-1 function, think about that. Without using whatever here, I'm gonna give you this function. Without using this way, can you tell me how you're gonna figure out it's 1-to-1?
You equal it to 0?
No. Think about that. I'm always telling you, think out of the box. So you can figure out the function is 1-to-1 by graphing this function and then using the horizontal line test and the vertical line test. But now our goal is to show that if you take 2 points from the range, it's going to be the same points of the domain. So now tell me how the points look like in the range. How does it look like? How the points look like in the range. Now, if I ask you, give me a point here by using this formula, by using this. This is the input, right? X. How does it look like the Y? This is the Y. The Y look like this. The numbers in Y look like this. Because you get the idea? Because the number on Y, you multiply the X by 3 and you add 2. So this is the shape of Y.
It's going to be 3, and then the Y is going to be 3, the X.
This is the X. So when I give you 5 as an X, the Y, you can multiply the 5 by 3, and the result you're gonna add 2. So this is the shape of Y, and this is X, the input. You get the idea? So now, if you choose A and B, how is going to be f of A? Here's the equal sign. How does it look like if I'm telling you find f of A based on this function, which is mean find the Y for A based on this function? How does it look like? It look like 3A plus 3 plus 2.
Find the Y.
Y, this one is mean Y equal Y. Y1 equal Y2. You get the idea? When I'm telling you A, how is the shape of Y when X is A? Like this, right? 3 times A is plus 2. Now, for B, how is the shape of Y?
I think you would have
3 times B plus 2. 3 times B plus 2. That's what it means. Alpha fill A and alpha fill B. Alpha fill A should be equal. Alpha fill B. You get the idea? That's what we're doing here. Alpha fill A equal alpha fill B. This is alpha fill A. And this is alpha fill B. Now I'm asking you, can we simplify this one? Can I simplify? If I said -2 from both sides, if I say -2, -2, is that okay? Cancel 2 from here. What's the left? 3A equal what? 3B.
But
We divide.
You can divide it by 3. So what's the left? Is that what we have here? So we start from what? We started from alpha fill A equal alpha fill B. I'm gonna look how it look like the shape of the function. Just change the x with A and change the x with B. That means alpha fill A equal alpha fill B. Then I need to solve it. Yes, if I took 2 from both sides, took away 2 from both sides, it's gonna be 3A equal 3B. Can I divide both sides by 3? Yes, A equal B. So we proved alpha fill A, if I took alpha fill A equal alpha fill B, is going to give me A equal B, which is the condition if it's satisfied. This is what? This is 1-to-1 function, okay? Is that okay? Let's do the other example.
7 is not, right?
Hmm?
Number 7 is not.
It's not.
The exponent and negative times a negative is a positive.
Let's do the same thing. Let's do the same thing. Now I need to check alpha fill x, alpha fill A. What I'm going to write down, here's the cosine. What I'm going to write down here,
3A squared.
3A squared. Here,
3B squared.
3B squared. That was the next step. Divide by 3. So A squared equal B squared. That was the next step.
But square it.
You're gonna what?
You got a root.
You're gonna take the square root.
Square root.
Here's the question. If I took the square root here, and if I took the square root here, yes or no?
It's a negative.
So it's gonna be plus or minus square A. Let's do it A. And here is going to be plus or minus. So is that okay? This one going to be this the same thing here.
Supposed to look like that in the end.
It should be exactly the same thing. Why?
It's minus a-
Just a plus or minus, but the main thing that's mean if I took the positive A from here, how many B's? 1 positive, 1 negative. I'm just talking about the positive. And if I took the negative A, how many B? Also positive and also negative. So which is not okay. In both cases is not okay. Because 1% going to how many places? And if you do the opposite thing, it's the same thing. If you took 1 B here, it goes to how many A's? If you took the negative B, it goes to how many A's? So both cases not going to work. So it means what? It's not 1-to-1.
Look.
No, I agree with you.
Work.
It's gonna work. So if you know how to graph it, you can find that it's 1-to-1. I'm not gonna say it's wrong. Always there is more than one way to find the solution. This one and the other graphing. As I showed you with this one, yes. Here is the graph for the parabola. Satisfy the first condition, satisfy the second condition. It's not gonna work. It's not 1-to-1. That's it. Done.
So you gotta memorize how it looks because I don't.
If you're not memorizing how it looks like, about the basic function, what are you gonna do? Graph it. Pick points, find the y, and graph it, you'll be fine. You have to know the domain. Even if you don't know the domain, the range always going to be positive. But always, I told you before, when it's squared, cubic, fourth, fifth, always make sure the domain negative and positive. When it's roots, only the problem with even roots. When you have even roots, the domain is not going to be negative infinity or positive infinity. Like the square root of x. How are we going to graph it? What's the domain? Yes, which is from 0 to infinity. So we can't choose negative numbers because it's going to be complex. It's going to be I, negative sign, it's going to be an I. You got the idea? So the domain from 0 to infinity. You got the idea? So that's just like to refresh your memory about the graph. We need to prove that they're going to give you two functions. And they're going to ask you prove that these two functions are inverse to each other. So what are you going to do? You're going to take f composite with g of an x, and then you're going to go back and take g composite with f. Okay? And the result should be equal what? Equal x for both functions. Or not just equal x, equal exactly the same result, okay? Here's the rule. So check here. If they give you a function f, what's that mean here? This is the inverse. This is not exponents. Because it's a function, it's not a variable. So be careful. When you see a function with negative sign, -1, it's mean the inverse of f, because f is a function. So now, f composite with the inverse of x equal what? And the inverse composite with f of an x equal what? Equal also x. Is it okay? We're gonna do that with the next example. So they gave you two examples. They're telling you, we don't have a class. Give me 1 second. Okay, they gave you now two functions. They're telling you f of x equal what?
3x plus 6.
Plus 6. And g of x equal 1/3 x minus 2. They're telling you prove that these two functions are what? Inverse to each other. How are we gonna check that? The first thing, we need to find f composite with g to the x. And then we're gonna prove what? G composite with f to the x. How much is going to be? We have to get the same value, which is the value of x. We need to get x from both sides. If we got x from here and x from here, that's mean this function is inverse to the g and g is inverse to f. Is that okay? So now let's check. F circle or composite with g. Which function is out? F is out and g is inside. Here is g of x. Is that okay? So no. Now, here is f. Where is the function g? There, I'm gonna put there x. Is that okay? Now I'm gonna plug in the whole thing here where in
X.
inside x with the f function. So I'm gonna plug in the whole thing here. So it's going to be, here is the 3, open parentheses, 1/3 x minus 2 plus 6. Is that okay? What's the next step?
Multiply.
3 times 1/3. 1x, right? 3 times -2, -6 plus 6. -6 plus 6, 0. So what's the left? X. So from the first part is right. We get an X. We need to prove that the other one. Is that okay? Now with the second one, which one is out? P is out, and here is f of x. Here is g. F of x, that means the whole function here, which is 3x plus 6. Is that okay? Now I'm gonna plug in 3x plus 6 where? In the g function. So here. So it's going to be 1/3. X is going to be the value of 3x plus 6 minus 2. Now 1/3 times 3x. 1/3 times 6, no, 2. 1/3 times 6. So it's going to be what? 2 and minus 2. 2 minus 2 is 0. So what's the left? X. What does that mean? That means we proved that f is the inverse of g and g is inverse of f. Is that okay? By using composition. So let's see the next one. We have f of x equal x plus 1 over 5 and g of x equal 5x plus 1. So I'm going to say I need to find f composite with g to the x, and I need to find g composite with f to the x. On this part, f is out. Which one inside? G of x. Here is f is out. G of x is 5x plus. Now I'm going to plug in 5x plus 1 where? So it's going to be 5x plus 1 over 5. Let's simplify. 5x, 1 plus 1, 2 over. Can I simplify it more? You can't. You can't cancel the 5 with the 5.
No.
I'm gonna give you 0 if you do that on the test. Don't cancel the 5 with the 5. Is that okay? Let's check the other side. So g is out, and here is f of x. Here is g. F of x is x plus 1 over 5. Now I'm gonna plug in everything here where? In the g function. So it'll be 5 over 5 plus 1. Can I distribute? So check here. Can you cancel 5 with the 5? Yes, now you can, because there's multiplication between these two terms. So if I cancel these, the left is x plus 1 plus 1, which is going to be x equal plus 2. So do we have x from both sides? Or even equal result from both sides? No. That means f is not an inverse of g. G is not inverse of f. That's it. So as I said, on the previous example, they give you two functions and they ask you to find it, to prove these two functions are inverse to each other. So that's why we have to do the composition. But now they ask you to find the inverse. Like example 10, our function f of x equal what? 2. Is that the right one?
That's what.
2 plus half x. I don't care about how it's look like. I'm just gonna do the steps. What's the steps it says? So the first thing, we need to find the inverse for this function. The step 1, replace f of x by y. So I'm gonna say y equal 2 plus half x. Okay. Now, if I ask you here, this function is already solved by for y. It's already solved for y. Now we need to go back and resolve it again for x. That means I need to keep x by itself on one side. So I'm gonna do the opposite relation, okay? Interchange x and y. Oh, we have to do interchange before that. Replace f with x by y, and then we're gonna do interchange x with y. So how is going to y is going to be what? And 2 plus half y. Is that okay? This is step 2. Step 3, what we're gonna do?
Solve for y.
Solve it again for y. But before I used to be solve it for x and then replace. So it's the same thing. Let's follow these steps. And solve it for y. How am I gonna solve this one for y? That's mean I need to keep y by itself. What am I gonna do?
First you subtract 2 and
So first of all, -2 from both sides. Perfect. Cancel here. So it will be x minus 2 equal what? Half y, right? Next step. Multiply, divide by half or multiply by 2. So multiply the whole thing by 2. So it's going to be, here's the 2, right? X minus 2 equal half times 2, and here's the y. Cancel this one, what's the left? 2x plus, I put the plus. 2x minus 4 equal what? Y. So step 1, we did step 1 here. This is step 1. Step 2, interchange. This is step 2. This is step 1. This is step 1. Step 2, step 3, the whole thing here. We solve it for y. Is that okay? Now step 4 is what? Just replace y with the inverse of f. That means y equals 2x minus 4. That means the inverse of x equal what? Minus 4. Is that okay? There's not that much hard. You just have to know how to use the steps.
so that's the inverse of the word, right?
That's the inverse of the function. Now, if I ask you, how are you gonna check it's the inverse of f?
Divide it, right?
No, I have, this is the inverse, and this is the function, right? This is, tell me the function, 2 plus half x, right? And this is the inverse. We found the inverse is what? 2x minus 4. There will be extra point on the test. How are you gonna check this one is the inverse of this one?
It's like adding and subtracting, you just do the opposite.
Well, say it again.
Find the composite. Put it into
We
the.
already did that here. This is two functions. How are we gonna prove they are inverse to each other? We're going to do the composition, right? We did composition F circle G, and we did composition G circle F. And we found the two values not equal, so they are not inverse. Now, if I need to find its inverse, they have to get x here and x here. So the same thing here. So if I have to prove F composite with inverse to the x is going to be equal what? X. And if I switch it, if I say F inverse composite with the F function to the x, the result should be what? X. And you can check that 100%, the both result is going to be x. 100% it's going to be x from both sides. How to find the inverse of this function? What's the first step? Change this one with y. So y equal Just change f of x with y. This is step one. Step two, interchange x with. So this one's going to be x equal 3y over y plus 1. Is that okay? I don't know. Now what's the next step? Solve for y. We need to solve this one for y. How am I going to solve it for y?
Multiply by 1.
I'm going to multiply everything perfect by y plus 1. It will be x times y plus 1 equal 3y over y plus 1 times y plus 1. Cancel these. What's the next step? The left is x, y plus 1 equal 3y. Next step, you need to solve for y. What I'm going to do next? No, before that. But I have y here. But I need to keep all the y's in one side. I have to distribute the x. So x times y, xy. X times 1 equals 3y. Is that okay? Now what's the next step? I need to solve it for y. That means I have to keep y by itself on one side. I have y here and I have y here. What I'm going to do to this y? Move it to the other side. Can I say minus xy? So minus xy. Cancel from here. What's the left? From the left side, just x equal what? 3y minus xy. Is that okay? Kind of you lost?
That's because I did mine backwards, so I'm over here.
It doesn't matter. Now what's the next step? I need to solve it for y. So I have to get only one y on one side. I'm gonna get one y from here. Can I take the one as the y as a common factor between these two terms? Here's the x. Can I say y? What's the left? 3 minus x. Can I do that? Got it? Now what's the next step? I'm gonna keep the y by itself. Divide by 3 minus x. So y is going to be equal x over 3 minus x, which is mean the same thing. Y equal x over 3 minus x. Y, the last step, replace y with f inverse to the x equal what? Okay. Again, do the steps. But if you look at this example, they give you the fraction of x equal plus 3 with this condition. You have to be careful. What's the first step? Step 1, we need to replace y with f of x with y. X squared plus 3. And the condition is that okay? Next step is what? Change y with x. So here is x equal what? Y squared plus 3. Change the condition to. That's important. Okay, because we need to find the condition for the inverse. So when I change the y with x and the x with y, I have to change the condition. Next step, solve it for y. How are we gonna solve it for y? Move the x, move the 3, minus the 3 from both sides. Will give me x minus 3 equal what? Y squared. Next step, I need to find the value of y. So I'm going to take the square root of both sides. Square root of y squared, square root of x minus 3. How much the value of y? Plus or minus. Now, how many value I have for y? I have two values. But don't forget we have condition. Y only when x, when y greater than or equal 0. Where is it? Take only positive numbers. So how much the value of y? Y equal only the positive x minus 3. Replace, so f inverse to the x is going to be only the positive values. Is that okay? Of course, with the condition y greater than or equal 0. We already know the inverse f and f inverse. This means the inverse of the function, right? What about if I give you, I'm telling you f of x, this is not on the, this is not on the notes you have. If I gave you f equal, function f equal 1, 2, 4, 3, 5, 7. Let's do it -3 here. If I give you this function, how much is going to be the inverse? Can't use the 4 steps we had. What's the inverse?
Just flip the signs, or we can't do that.
The numbers. Switch the numbers.
Flip the numbers.
We'll flip the numbers.
Remember before we had the two columns, x and y. This is the function. The function take the person to the place. The function is the car. The function f is the car taking the person 1 to place 2. Okay? The inverse is the same car, but taking the person from the place to where? To go back home. So this is the inverse. Here it's going to be. You get the idea? It's one opposite the other one. So to find the inverse, this one's going to be x and this one's going to be y, the opposite thing. So I just have to flip the points. The inverse is 2, 1, -3, 4, and what? 7, 5. Gone. That's it. Because there is just flip the points. That's it. This is one going to be the inverse. Now let's go back to the last question. So now they ask you graph this function. Oh, here is the function. Graph what? The inverse. With this graph, they're telling you can choose these points. But when you're working on Alex, you're not gonna see the points. You have to pick the points. And don't pick points with decimals. Pick points exactly on the graph. It's gonna be easier. So you're gonna take the points. So I know the points for F is going to be this point, which is 1 and 4. And take the other point, on -1 and 2. Another point, this one is 1, 2, 3 and 1. And the last point is going to be 1, 2, 3, 4. That's mean -4 and
-2.
-2. So here is the point. I'm gonna go ahead. The inverse is going to be 4, 1, 2, -1, 1 and 3, -2 and -4. Go back and graph these points again. 4, 1, 1, 2, 3, 4, and 1. Here is the point. 2, negative 1, 1, 2, negative 1. Here is the second point. 1, 3. This is 1. 1, 3. 1
Should be -3.
should be what? 1, 3. It's a 3, 1.
The left.
Oh, yeah, you're right. It's a 3. It's negative 3, 1. Perfect. So it's going to be 1 negative. That's why it's a 1. 1 negative 3. So here's 1 and negative 3. 1, 2, 3. I did the other one. 2, negative 1. 2, negative 1 here. And 1, 3. Another one is what? Negative 2, 4. Negative 2. And 1, 2, 3, 4. Makes sense to me. This is 4, 1. 1, 2, 3, 4, 1.
1 and
This is 2, negative 1.
1 and -3.
And here is 1, negative 3. And the last one is 1, 2, 3, 4. Negative 4 and negative 2. So it's going to be negative 2, negative 4 here. This is right. This is right. And
I move the 1 and -3.
The points are 1 now.
which point? This one?
So you 1 up.
Oh, it's 2.
2 and
Should be 3. Perfect. Now it makes sense.
Move down.
It's not
Yeah, long
easier.
day,
if
huh?
you write 'em. It's a lot easier if you write them than you try to do it in your head. I tried to do it in my head the first time and I just confused myself.